get all the way through. But we'll do as much as we can today, and then we'll finish up Wednesday, and then whatever time we have left, we can just review. I posted a study guide on Moodle under the review for test 1. I've got problem set, and then I've got a problem set that has the answers. It doesn't have the step-by-step solution, it just has the answers.
Are you using these on
3.4 and 3.5?
They're not.
They're not on there? Yeah, I'll post them. I'll do it. Actually, maybe I can just do it right now. Sorry about that. It's up there now. Sorry, it's not there ahead of time. I'll try to go slowly. You can write them down. So, okay, so now we're going to talk about measures of position and outliers. So we'll start off with just z-scores, which I think we talked about before previously. Did we do z-scores before? This didn't matter. Okay. That was a different class. Sorry. Teach you at a different school and your schedules are kind of off. Okay, so we'll talk about z-scores just briefly. These are going to be used a lot more once we get to chapter 7 and beyond. We're going to do a lot with z-scores. Right, which means we haven't talked about the empirical rule yet, so you can't do that problem from 3.3. Did we talk about the empirical rule?
We talked about
Oh
that.
my goodness. Okay, I'm sorry. I'm all scatterbrained. Okay, so sorry. Let's talk about z-scores now, and then we'll talk about percentiles just briefly. The problems on the homework, you don't have to actually calculate percentiles. You just have to interpret those. So those aren't going to be too difficult. And then we'll talk about quartiles. And once we have quartiles, we can do a lot of things like the interquartile range, figure out outliers, and then we can draw box plots and do the 5-number summary. Okay, but the first thing we're going to do is the z-score. So for this one, it's just going to be z-score, because that's what's in the title. So just write that down, the z-score. It represents the distance that a data value is from the mean in terms of how many standard deviations. So it tells you how many standard deviations you are above or below the mean. They give you the formulas for population and sample. It's pretty much the same basic concept. You just take whatever your data value is, you subtract off the mean, and then from there you divide by the standard deviation. So if you have a population, you've got your mu and your sigma for your mean and your standard deviation. For your sample, it's just an x bar and an s for your mean and standard deviation. It's the same basic concept. The z-score is unitless, so it doesn't matter what your units are. If you've got two different data sets, and one's feet, one's inches, it doesn't matter because your z-score is going to be like a ratio, so it doesn't matter what the actual units are. And then the mean is 0, the standard deviation is 1. We're going to talk more about that when we get to chapter 7. But for now, we're just going to calculate a z-score and interpret what that means. So they tell us the mean height of males is, bless you, 69.1 inches, and the standard deviation is 2.8 inches. But for females, the average is 63.7 inches, and the standard deviation is 2.7 inches. And then they ask you who is relatively taller, these people here. So you've got Kevin Garnett is 83 inches, Candace Parker is 76 inches. Both of them are tall. And then you can see Kevin Garnett, he is taller than Candace Parker, but if you look relative to their genders, who is going to be taller, we're going to calculate the z-score to figure that out. So, and the reason for this is we've got my best friend in high school, Ashley Wacker, was 6 foot tall, and everybody always commented on how she was tall and must have played basketball and all that stuff. But my brother, he's 6 foot tall too, but nobody ever said anything like that to him because he doesn't seem as tall even though they're the same height, because he's a guy. So that's kind of the idea behind this question, what they're asking. So we have to figure out what their z-scores are. I'm going to write it over here. So actually my marker isn't working that well. Maybe I will just use my my computer, sorry. Right over here. So we do Kevin Garnett first. Okay, since he's, well, his value is 83 inches, that's his X. That's actually what his height. So this X up here, maybe not that one, this one here, that X is going to be your individual score. Your mu and your sigma are the mean and standard deviation, but your X is your individual score. Or height in this case. And then his mu will be 69.1, and his sigma will be 2.8. That from here and here. All right. So if we do his z-score, it will be 83 minus 69.1 divided by 2.8. 4.96. Okay, so he's almost 5 standard deviations above the mean, which is quite a bit, because when we talked about the empirical rule, most scores are going to be in between, within 3 standard deviations. So he's quite a bit taller than that. He's 5 standard deviations. And that's what they put down here. Kevin Garnett's height is 4.6 standard deviations above the mean. So he's definitely very tall. Switch over. Okay, so if we do the same thing for Candace Parker, her individual score or height is 76 inches. And then if we look at her mean is different because she's female, so her mean is 63.7 now, and the sigma is 2.7. Since they come from different groups, male and female, they've got a different mu and sigma. So if we calculate her z-score, we'll do 76 minus 63.7 over 2.7. So for her, I get 4.56 when I put it in my calculator. She's 4.56 standard deviations above the mean, which is still very tall. But since Kevin Garnett has a higher z-score of 4.96, that's higher than the 4.56. So since his z-score is larger, we're going to say that he is taller relative to his gender than Candace Parker is. So that's what a z-score represents. I do have another example down here. So first of all, I'm going to change this. This says 5, 5.5. I'm just going to write it as 65.5 inches, just so we don't have to convert it, go through that extra step of converting it from feet to inches. Okay, so that's his z-score. That's his, that's his height. We're trying to figure out his z-score. So his x is 65.5 inches. His mu, since he's a male, he's going to be back to the 69.1, same as Kevin Garnett. And then sigma